So looking at 10.2 here. So 10.2, a hypothesis test for a difference of two means. So like I said, 10.2, we're talking about two means. 10.1, again, 10.1 was two proportions. Now we're doing two means. So on the test, we'll have the practice test to help straighten all that out. All right, let's dive in. Do political science classes require less writing than history classes? These are more interesting. I think the applications get... What I like about teaching stats as opposed to algebra or something is it's very real. And especially as we get here near the end of the course this last month, it's more and more real. We have more and more skills, so we can answer more and more real-life type questions. I think it's kind of interesting. Do political science classes require less writing than history classes? So notice right away we're comparing two things, aren't we? That's what this whole chapter is about. So we're talking about how much writing, science classes versus history. The 47 randomly selected political science classes, so they just, to answer this question, they grabbed some data. So they grabbed 47 poli-sci classes, and the average was 14.2 pages of essay writing for the course. The standard deviation for these was 5 pages, right? Because there was some deviation, you know what I mean? So they, is that your average in a science class? I don't remember writing anything in science classes. Anyway.
Political science.
Yeah. Oh, political science, thanks. I'm getting confused. Yes. Poli-sci, you do have to write, don't you? Yeah. So, yeah, political science classes. Yeah, so 14.2 pages on average, but there was a standard deviation of 5 because, it's not all the same. And then, that came from a sample of 47 people that took poli-sci classes. And they asked them, how many pages did you write? And they all gave their answer. And the average was 14.2, but there was some deviation. The average distance from the middle was 5 pages from that middle. Now, then they asked 56 randomly selected history classes, and they had 16.1 pages. Looks like the history's more, huh? 16.1 pages on average, but they had a standard deviation of 3.5. Right? They weren't all right on the average of 16.1. Some were above, some were below. Average distance from the middle, 3.5. That's called standard deviation. What can be concluded at the alpha 0.05 level of significance? So how do we test this kind of thing? Let me write that here on the notes. So what I'm saying is in 10.1, which was two proportions, we did the 2 prop z test, and now in this section 10.2, two means independent, and we'll talk about what that means tonight. Independent, we're going to use the 2 sample t-test. That's pretty much the whole, actually that's not true. That's for part of them tonight. That's 10.2. 2 sample t-test. So we go to the 2 sample t-test on your calculator. So I think this answer, what does it have here? Is it just like a t? Is that what they want there? I know some of you guys are on the homework. Yeah, t there. All right, so t, because we're doing 2 sample t-test. And then, we got to write the claim. All that's the same. And so let's do that. What's being claimed, or what's being questioned? How about that? Do poli-sci classes require less writing than history? So that would be the average 1 is less than average 2. See how I put the less sign there? And we're letting U1 be whatever it is, poli-sci. Political. I'm just going to go PS, poli-sci. And the mu2, that is history. History. We good there? So that's what's being wondered. Is poli-sci less writing on average? See why I'm using mu? Because we're talking about averages, means, not percentages. Remember last time it was all questions like, honestly I don't remember. percentages of things. So that's all I can say. So this time it's not percentages, it's average, like average amount of pages of writing. So that's what's being claimed. mu1 is less than mu2. All right, and so what am I going to do for HO? What's HO always? Equal. So mu1 equals mu2. And then H1 has got to match the claim, right? mu1's less than mu2, just like the claim. And then you know the rest. It's always weak evidence for the first one, strong evidence for the second one. Like that. All right, so we'll go over and write that. So this is mu1 equals mu2 and mu1 less than mu2. And the test statistics, so we go to our calculator now, go to two-sample t-test, and put in the information. Let me grab the information out for you, just to make it easier. So we're going to have, I'll put it over here on the side. We're going to have a mu1. So that's the average for the first group, which is the poli-sci. Poli-sci. So the mu1, you see that's the 14.2. That's the average pages, poli-sci. They want mu1. What else is it? It's just mu1. And then, S mu. I'm going to have to look. Yeah, so you have to choose stats because we don't have data, do we? You know, there's not like 10 numbers. There will be in a couple minutes. But for this one, there's not a list of 10 numbers or anything. Just choose stats. And then they have, it's actually x1, s sub x1, so it's not mu1, huh? It's x1, s sub x1, and then n1, right? Yeah. And so that's 14.2. Where's the standard deviation? 5 pages. And that's 47. That was 47 people, or classes, 47 poli-sci classes. And then the other one, history. So they surveyed a bunch of history classes. That'll be x2. And the average for those was 16.1 pages of writing are required. The standard deviation for that group was 3.5. And the N2, the number, that was 56 randomly selected history classes. So there we go. See how I'm grabbing that information out? And then you just put that in your calculator. Like so. It's a no. And it's always no. So for pooled, just say no. Now, what it means is you could pool all the data together to get a standard deviation for both groups all together, and it'll make something come out a little different. We're never going to do that. That's more advanced. It's just more advanced ways they can do statistical stuff. So for us, it's a good question. The pooled question will be coming up in a lot of situations. It's always no for us. We're not pooling together the two groups to form a common standard deviation. We're using the two separate standard deviations. All right, here's what I'm getting. I'm getting the test statistic, the t, equals, how many decimals? They want 3. Okay, negative 2.193. We good there? And what about the p-value? 4 decimal places. So 0.0156. 0156. You guys getting that okay? Coming out. And so is that p-value, is it greater than the alpha or less than the alpha? I think it's less, isn't it? So the p-value is 0.0156. The significance level, that's what we always compare it to, right? With hypothesis tests, I think you know this pretty well by now. 0.05 is the significance level on this one. Yeah, so that p-value is certainly less, isn't it? 0.01 is below 0.05. So the p-value is less than the alpha. And what does that mean when the p... So is that p low or not low? It's less, it's low, huh? P is low. So what does that always mean when the P is low? HO must go away. So the HO must go away. So come up, cross out the HO, or right here, I guess, wherever, and keep the H1, huh? So we're going to reject the null, because the P was low, the HO must go, the null must go. Reject the null. And is there strong evidence or weak evidence? Strong, right? We're ending with the strong evidence. So I'll go to a fresh screen and we'll see if you guys got that down okay. We'll see if we can answer the question. So on a fresh screen, so again we had HO, H1, mu1 equals mu2, mu1 less than mu2, and this was weak, strong. We crossed out the null. We took this one, strong evidence. All right, so statistically significant, huh? It's going to be one of the ones that says statistically significant. So it's either the first one or second. Oh, wait, I'm getting confused. There's three of them?
No, the second
Oh, yeah. That's a two-letter. Yeah, it's even worse than a not, huh? Yeah, that's small to see, especially under the pressure of a test, huh? Yeah. Good eye, Zach. All right, so it's the first and the third one. It's either the first or the third, right? We good there? Because those say statistically significant. So which one's right? What else is going on there? I don't even know. Is it? Why is that? What's wrong with the first one? So there is sufficient evidence. And this one says the same thing. To conclude that the mean number of pages that were observed is less than. That says the same thing here. Is less than what? The mean number of required pages?
Or the population.
The population mean number. Which one is it? It's always the population. This is the one. We're always wanting to try to determine something about the actual population, not the 56 history classes, right? We're just using the 56 history classes to tell us something about all history classes. Does that make sense? Remember, that's how stats always works, right? You're always measuring something from a sample so you can learn what's true of all all political science or all history classes. So that's what they're trying to get you on there. It's always about the population that you want. We good there? Does that make sense on that? Questions I can answer? Try to go forward there. Go forward to question 2. Number 2, do shoppers at the mall spend more money on average the day after Thanksgiving compared to the day after Christmas? What do you think? This is kind of timely. More money the day after Thanksgiving or more money the day after Christmas? You don't spend money the day after Christmas, do you?
No, shouldn't it be the day before Christmas?
I know. Who spends money the day after Christmas? What's that? Getting the deals. You're on it, huh, Christina? That's amazing. Anyway, so I would say they probably spend more money the day before Thanksgiving. Anyway, let's just grab the data there. So 54 randomly surveyed shoppers spend an average of $128. Standard 41. Christmas, day after Christmas shoppers, average of $122. Standard 50. What can be concluded at the alpha 0.01 level? Hey, I might want to skip this one. Or we could do, okay, do you want to do one more? All right, we'll do one more of these and then we'll skip on ahead. Okay, so let's give it a try. So I'll quit skipping around. So it's going to be the same thing, right? You just have to pull out the 6 numbers. There should be, an X bar. There should be, like an X1 bar. S sub x1 and an N1, and then there's going to be an x2 bar, an S sub x2, and an N2, right? So we just always have the first population and the second. This time it's Thanksgiving and Christmas. Last time it was the poli-sci class and the history class. And you just have an average, a standard deviation, and a number in the sample for each. And just pop them into the two-sample t-test and see what comes out. So I'll put the numbers here. The average was $128 for Thanksgiving. This one over here is Thanksgiving. This one over here is Christmas. So 128, standard deviation was 25, and that was 54 random shoppers. And then the second group, it was 41 shoppers. Yeah. 41 shoppers. Average was 122, and standard was 50. All right, so put all that into the two-sample T. Two samples. So now we're dealing with two samples all the time, aren't we? There's two proportions for 10.1. It's two samples for 10.2. Or the null or anything. I just jumped into. There's so many numbers. Yeah. All right. So I better. All of a sudden I got down to the greater than, less than. I had no idea. So what's being claimed or questioned or whatever on this one?
People on Thanksgiving spend more than Christmas.
Yeah, they're saying do the shoppers spend more Thanksgiving. So that means, again, we're going to have mu1, mu2, more, so greater. Huh? More is greater, less is less. I think you all know that. And the HO and H1. And the HO is always equals. And the H1 is the greater. And then the evidence is always the same. Weak evidence for the HO. Strong evidence for the H1. All right, now we go to our calculator. It'll be that way rest of the course. Pooled is no. And calculate. So I'm getting, what am I getting? I'm getting a test statistic. T, maybe I'll go to fresh screen here. Yeah. So I'm getting T, and I'll write the null over here. HO, H1. And this is the weak and the strong evidence. All right, and I get a t-value 0.704, yeah, 704, and a p-value 0.2421. And then the question, like always, is the p-value, how does it compare to the significance level? 2421. The significance level is a 0.05. Oh, 0.01. There it is. At least on mine. It's 0.01. The p-value is certainly greater. So that p is not low, huh? My p is greater. It's not low. So that means HO does not go away. So HO does not. So I'm keeping HO, huh? Keep HO and get rid of H1. At least in mine. So, but the HO does not go away. The P was not low, so the HO does not go away. So we keep the HO. And so the p-value was greater than the alpha. Based on this, we should, is that reject the null or fail to reject the null? Yeah, fail to reject. No, we did not reject. Fail to reject the null. And then what does that mean about the conclusion? Is the evidence, is it statistically significant or not? Yeah, it's not, huh? Or it's I guess they're saying insignificant. So the evidence is weak, So that is statistically insignificant. Insignificant. So we're going to get rid of that significant. Get rid of that significant. So it's insignificant, insignificant. And probably one of those talks about the population, and one of those does not, I'm guessing.
The fourth one is a trick.
Oh, is it?
Yeah, read after the comma.
Let me see. The results are statistically insignificant, so there is statistically significant. No, what, they switched?
I think it was just trying to trick you.
Yeah, they are. That's crazy. Yeah, then all of a sudden they went to significant. Yeah. Insufficient evidence. The third one's right, huh? Insufficient. Yeah, there's our answer.
Funny how I can read that crap when I'm not taking the test.
It's easy to see from here, huh? So there we go. All right, so here we have question number 5. I'm going to jump forward to question number 5. Do men score lower on average compared to women on their statistics finals? Do men score lower than women on their statistics finals? You know, I feel like I'm kind of an authority at this point on this topic. I've been teaching for a lot of years, like 27 or, I don't know, 25, 26, 27, something like that. Anyway, and I've had a lot of men and a lot of women in all my classes over the years. Do you know which group does better? The women dramatically so, quite a bit better. I mean, there's always exceptions. There's some really strong men at different times, but usually it's the women. You know, there's more women. I heard a stat just this weekend. There's more women enrolled in college in the United States now more women than men now in the United States. Because the young men are at home playing video games, right?
Video games.
What's that?
You can make a living playing video games.
Yeah, that's what. All right, so who does better? Do the men score lower? Probably. Yes, probably. Let's see how the stats bear out. All right, so anyway, they got now. So this one's a little different. What's different on this one is they're giving us data rather than like the average. You know, last time they gave us the average. You know, they would say the average for the men, average for the women. They're just listing the numbers. So there's them, you know, how the men did in the final, how the women did in the final. So what do you think I'm going to do with, what do we always do when they give us a list of numbers? Yeah, but yeah, and this time we have 2 lists. So it's going to, normally we just have one list and it goes in L1. We have 2 lists, so L1 and L2, exactly. Just put the first list in L1, put the second list in L2. Okay, yeah, so first step, put the data in L1 and L2. No big surprise there. And then step 2, we're still going to do the 2 sample t-test. But this time when we do the 2 sample t-test, that first option which says data or stats, I'm sure you know, we're going to choose data this time, huh? Which is actually nice. There's less to do when you choose that. Less to enter since we've already put all the data in there. So 2 sample t-test, go over to data, and then they're just going to ask us, where's list 1, where's list 2, and you want those to be L1 and L2. Probably it already is. And they'll ask you frequency 1, and you just want the 1. The frequency stuff, we always just make those 1. Frequency 1, frequency 2, both 1. And then, I forgot to do I'm skipping the claim, HOH1 again. Claim, so the men do lower. Men do lower. Men are the first list. L1 is the men. So the men is lower. Mu1's lower than mu2. That's what's being claimed here. So the HO is equals, like always. The H1 is less. Because that's the same as the claim. Weak evidence, strong evidence. And that should take care of it. And then H1 is less, so we're doing a less test here. So you really don't need to put in anything. And the pooled is no, always. Pooled. We're not pooling the two groups together. Pooled is no. And calculate. All right. So I got a bunch of data. I'm going to go to fresh screen. So what was HO was mu1 equals mu2. And this was mu1 less than mu2. And test statistic, I got a t-value equal to negative 30.824. And the p-value. Now for my p-value, you guys getting this? Or something like it, if you're doing a different version? I'm getting 2.2 e minus 12. Remember what that means? That decimal needs to go 12 places back, huh? 1, and it's to the edge. 2, 3, 4, blah, blah, blah. It's going to be 0, isn't it?
Yeah.
It's just going to be 0.0000, so I'm just going to say 0. Which, whenever the p-value comes out 0, you know that's less than anything. So the p-value, I don't even need to look at the significance level. It's less, right? That just means there's basically no chance of luck. That's like me flipping a coin 20 times in a row with heads. You know it's a cheaty coin. We know there's no chance of luck. Something's causing that. So we know that the men are really, really worse. And it's not by luck, is what we're saying. So the p-value is really, really low. So when the p is low, HO must go away. So I'm going to come and cross out HO, circle H1, and that means strong evidence, huh, for H1. Right, the null went away, the weak evidence went away. The strong evidence is what we kept. So we keep the strong evidence and try to draw one of these conclusions here. So are the results statistically significant or insignificant? What is strong evidence? Statistically significant, huh? It matters. It's strong. So insignificant, no way. Insignificant, no way. So it's one of these last two. I don't see a difference. Is this where they do it's a population thing or not? This one has population, that's our answer. See how this one has mean for the 12 men? We don't care about the mean for the 12 men. We're using that to tell us something about the overall population of all men. And if all men do worse on average in statistics classes on their finals, right? That's what we're trying to determine. So we want the population.
I didn't get any of those numbers.
I didn't either.
Okay, so this is crazy. This is all wrong. Let me go back. My t is not that. It's not that. My t is negative 1.634. Is that what you're getting?
Yeah.
Oh, good. And my p-value came out not to be 0, but to be 0.0585. Is that right?
Yeah.
All right. And now, is that lower? I think it's above, so it goes the other way. It's all wrong. Everything I did was wrong. Yeah, alpha's 0.01, certainly. Yeah, so the p-value of 0.0585 is greater than the significance level of 0.01, isn't it? So everything I said is wrong and not true. So it's greater. So then it's the other way. We should, the p is not low, so I'll write here not low. So HO must not go away. So I'm actually going to keep HO. Let me go back and fix that HO, which said mu1 equals mu2 weak evidence, and the other one was mu1 less than mu2 if there was strong evidence. So HO is not going to go away. So I'm going to keep HO and cross off H1. All right, so the evidence is weak, it turns out. The evidence is it's statistically insignificant. It's statistically totally insignificant is the deal. All right, so it's either this one or this one. It's not these two. Which one of those is right? Oh, this one says insufficient evidence. That's right, yeah. Insufficient, huh? And this one went back to significant, which is wrong. There we go. We good? Thanks for the help on that one. Questions on that? All is well on that then? So we've seen two types. I'm going to dive into the next section. But let me just mention, so we've done 10.2. And well, up to now we've done 10.1 and 10.2. So 10.1 was two proportions, two prop z tests. 10.2 was two means. We did it two different ways with a list of data or not, but it's not very different. And this question 6 is the same thing. So they got a bunch of data, and we put that in. All right, we good there? So I'm gonna leave that off if you're good there, and I'm gonna go to the next section. As we do, I want you. In fact, let me segue right now. I want you to notice what's going to happen. This is what's going to be one of the trickiest things, sort of. I mean, it's not dramatically so, but one thing that's a little bit tricky to get used to recognizing. The next section will look that we're about to jump into will look like this. They'll always have lists of data, and the difference will be the data in the next section will be matched pairs, not independent. What do I mean by that? I mean, is there any direct connection between those two numbers or these two numbers? No. That's just some male who got a 66 on the final, and this is some female who did way better than him, got a 99 on the final. Right? They're just some random male and some random female. Well, in the next section, you know what they'll do is they'll change that and they'll go husbands and wives, for example. Do husbands do better or worse in stats than their wives, And so these two will be connected, right? If they're a husband and wife, we would call that matched pair data, meaning there's probably some connection there. Like if the couple is really into math and science, then there might likely both be or both not be. Not for sure, not every case, of course, but data tends to come matched. If it's husband and wife, or if it's before and after. So I want to put that idea in your mind right now, because those will be all mixed up on the exam, and you'll be asking yourself the question: are those two data sets matched in pairs, or are they separate, independent from each other? These two are independent. It's just a random group of guys, a random group of ladies, and they took the stats test. Their final. Whereas if they made that husbands and wives, Or they, yeah. So I'll show you the other data, but just put that in your mind that sometimes it'll look the same in the data, but they're matched up or they're not matched up. These are not matched up. This is independent, two totally separate independent lists.